Okay. I'm gonna start by sharing my screen. Okay. First of all, thank you for joining to this workshop. I think it's very important that you participate in this because uh, different different to previous workshops that I held. Now I want to talk about some major changes that we done not only in the data set but also in the migration process itself. And these changes are intended to facilitate the manual curation. We we have a deadline, as you know, on November 24th, and we believe that using this new protocol, you will be able to advance in the number of reactions curated considerably. So before I begin, as always, I would like to thank you for all the advances that you were able to make in the manual curation of our reconstruction. We have a total number of 2,000, almost 300 reactions curated. We now have a vast amount of reactions, almost 1,500 reactions with a pre-check tag. I'm going to explain this in the next slides. We have 166 unbalanced reactions fixed. Many of you were able to identify at least 30 duplicated reactions, which it's a lot. It's a very big. It's a very huge job, and I really appreciate you taking the extra time to identify duplicated reactions by identifying the duplicated metabolites. And as I said previously to Don Hyuk here, each one of these reactions that you identify also counts for you as a curated reaction. So I'm gonna make sure to put this in the final counter of your curations. And finally, we still have some packages that have people didn't sign up for. It's not the case for the people in here. I know that all of you are involved in at least one package. So we still need to reach out to some extra people to help with the curation of these packages. And I also want to take this opportunity to invite you to curate these packages. If you believe that you're going to have the time to do so, and you already are almost finished your package or already finished your package, feel free to sign up for other package. This for sure is going to be it's going to be good for you in terms of the position in the publication. So major modifications in the original data set. Some reactions have a pre-check tag now. This pre-check tag is in the curated column. So to these reactions, we add the pre-check tag, and in the confidence score, automatically we set a 1. The pre-check tag reactions are those reactions that they don't have a GPR assigned to them and are present in more than one reconstruction. And the idea behind this is two things. One, we want to prioritize the curation efforts towards those reactions that are more important to curate. So the pre-check tags are reactions that are not priority number 1. So that's why we don't want you to curate them. And the other idea behind this is to facilitate the manual curation for you, because pre-check tag reactions are those reactions without GPR. So those are the most difficult to curate. The other reactions at least have a GPR in any of these columns. And when you have a GPR in any column, the first thing that you do is to check that GPR is correct, and it's much easier to curate. So the next thing that I want to talk about, and this is basically the bulk of this workshop is this new money curation protocol that we put together. So I sent in the newsletter a link to this new money curation protocol. After this meeting, I will send it again, and I highly recommend you to read it. It's super short. It's much shorter than the previous one. It's super straightforward. It doesn't have so many paths and so many databases as the previous one, and it's going to be comprised in this presentation. So basically, all the entire money curation protocol, the version 2, goes around this database called RIA, and this is the backbone of the money curation. And of course, the idea of this, as we did with the pre-check tag, is to facilitate and accelerate the money curation process. So we're going to go to the different steps of this curation one by one. And the first step, as in the previous protocol, is to retrieve information from the GPR already annotated in the reaction. So here I took an example reaction in which we have GPR in all the models and also GPR final. I wanted to take this example because this is a simple case to curate. You have the same GPR in all the reactions, and you already have a GPR final. So many people that already see a GPR final in the column, they don't curate that reaction because some believe that this curation is curated. But the fact is that if you don't see a confidence score, you don't see curation node, or even if you see curation node. But most importantly, if you don't see any curated tag in here, it means that this reaction needs to be curated. So we pick this particular reaction. It has this only GPR annotated. And the second thing to do is to confirm that this gene is a Chinese hamster gene. So we look for information on this gene in NIH. And when you enter to the NIH webpage, you can see the name of the gene. So the name will be this one, malonyl decarboxylase, Chrysotulus griseus. This is the Chinese hamster scientific name. And if you roll down on that big page to a section that says mRNA and protein, it will redirect you to the UniProt link. All the genes in NIH, at least all the genes that I've seen, have a UniProt link. So when you click that, it will redirect you to the UniProt webpage of the protein code encoded by this gene. And this is where you can find the RIA annotation based on your gene. So the thing is this: many proteins in CHO, they don't have RIA annotation. So what you want to do is to find the human homolog for this protein. And by doing that, you will find the RIA annotation. It doesn't mean it's another protein. It's the same. But for some reason, UniProt is not a complete database, so it doesn't have the same annotations for every species. So after doing this path, going to NIH, then to UniProt, you can check if the RIA database pops up in the function section of the protein. But if it doesn't, you go to the human version of the gene. So here is the note: many Chinese hamsters don't have a function or RIA annotation associated with them. So in that case, look for this information in the human version of the same gene. So here's the gene. You input this in UniProt. You select the human protein, and the first part of that database tells you the function and also the catalytic activity. And this is where you find the RIA annotation. So this is This is the link that redirects you to the RIA database, and this is a description of the reaction. And I didn't show you the entire reaction before, but basically this is the reaction that we are trying to curate. So we have now a candidate gene, and we have the description of the reaction. So the next step will be to go into the RIA database. Oh, sorry. We have a second way by which you can enter the RIA database. So first one will be by the GPR. We select the GPR and we do the path through NIH, UniProt, and the other way will be through the metabolites. You can also enter the RIA database and try to find new information through the metabolites. So this is the reaction that we are trying to curate. MCD is the name, and these are the metabolites involved. So these metabolites are IVs. With some of them, you cannot link them to direct metabolites. So what you want to do is to go to the metabolite sheet and try to find the metabolites involved. Here we take this metabolite as an example. And if you look for this metabolite in the metabolite sheet, you will find the name, malonyl coenzyme A, the formula, you have the PubChem ID, and the INCHI. So with this information, you can go to the RIA database and you can input the name of the metabolite, and it will show you all the reactions in which this metabolite is involved. And as you can see here, this reaction pops up, which is the same one that we saw previously in the unit when we try to look for the reaction through UniProt. So we definitely have a candidate reaction. Now we need to explore this database a little bit more in detail. So when we enter the RIA database, we will find different information. It's a long page, pretty much like in UniProt and NIH, in which you scroll down and you see different characteristics of the reaction. But one section that you definitely want to check out is the cross-reference section. So in this section, you have different annotations from different databases regarding the proteins assigned to this reaction. Also, proteins assigned to this reaction in this row, and then you have the EC number assigned to this reaction, gene ontology, KEGG, metaseq, and reactome. You want to take a look at this part in which you find the UniProt. Of course, if you also want to take a look at the EC number and corroborate that this is the correct EC number, you can also annotate this in our reconstruction in the attribute sheet. But mainly I want you to focus in this, in which you can see the proteins annotated in this reaction. So our reaction, as you remember, is described from left to right. Right? It's a unidirectional reaction. It's not reversible. So you have here evidence of 4 proteins that are associated to this reaction from left to right. If you click on this, you will find all the proteins associated, and in this case, all the proteins associated are the same ones as this gene here, the malonyl coenzyme the carboxylase gene. So we can actually try to go into that. So I can show you this firsthand. No. Here is the RIA database, open. And if you scroll down, you will find the cross-reference section. If you click here, you will find that all the proteins associated to this is the malonyl coenzyme, the carboxylase. And the reason there is 4 is because there are 4 different species annotated to this. It is important to notice that, again, not all the time you will find Chinese hamster proteins here. and that's okay. It's not because there is no Chinese hamster protein associated to this reaction, but rather because there is a lack of annotation here. So when you compute the final confidence score, the next step is you already check the reaction, that is correct. You already check the protein that are involved. So the next thing to do is to assign a confidence score. And I'm glad that Anne is here, join us. And if you Anne, have another idea of how to better assign a confidence score, please feel free to give us your advice. But so the confidence score should be based on the level of annotation of the CHO protein at the UniProt webpage and the provided references. So basically what we want here is for you to corroborate the existence of this gene in CHO. Even though there are different ways in which, even though we have annotations of different genes, CHO genes in the NIH webpage or the UniProt webpage, many of these genes are predicted or inferred by homology. Not all of them, the existence is actually corroborated. So we want you to be aware of that when assigning a confidence score, because if a gene is only predicted or inferred by homology, it will have the lowest confidence score, which will be 2. But if you're sure that that gene exists, I mean, it has been detected in CHO cells, either by at the transcription level or at the protein level, that's a much more strong evidence of the existence of that gene. In the curation notes, there could be a brief description of the directionality of the reaction and all the proteins involved. So you can put that the reaction is in RIA is described from left to right, and the proteins involved are the one that you assign, and also the existence of the gene in CHO cells or Chinese hamster. And this is very important in the reference. You put the RIA database link along with publication listed with the functionality that you identified and the existence of that gene. So this is pretty much the entirety of the protocol. It's, as you can see, is much simpler than the previous one that we introduced to you. And now I would like you to show you an example, which is a little bit more complex. And if you had any doubts in the previous slides, maybe this will be helpful to evacuate all these, all your doubts during this explanation of this protocol. So here's another example of a reaction created with this strategy. Here we have a kind of a more difficult reaction because this reaction has different GPRs annotated in the different columns, and it doesn't have a GPR final. So if you pay attention, these are the different GPRs that are annotated. First one are this, then there is none, and then you have these other GPRs annotated. And if you pay attention, you will see that there are only 3 genes in all this combination. And this is one gene, this is the other one, and this is the final one. So the question will be here, the question to ask is, which one of those genes are involved in this reaction? Are all of them or just a subset of them? And are there any more genes involved in the same reaction? So these are the questions that every curator need to ask themselves when they're curating a reaction. So first of all, we query the NIH database and we look at all the gene names. And as you can see, all of these genes are different versions of the aldehyde, the hydrogenase, sorry. So this is a very good very good news. I mean, all the genes, at least they must have the same function because they're part of the same family. So now we go to the RIA database, to the UniProt database, to make sure that these genes are involved in the same reaction. So again, I have the Chinese hamster genes. I look for the information in UniProt. In this case, I didn't find anything. So there is no reaction annotated to these genes. So I look for these specific genes, but the human version in UniProt. So when I did that, I found out that LDH1B1 and LDH2 are involved in this reaction, which is basically the conversion of an aldehyde to a carboxylate. And LDH4A1 maps to this other reaction. So these two are involved in this reaction, which is a very generic one, any aldehyde to any carboxylate. And LDH4A1 maps directly to a reaction that is involved to a glutamate semialdehyde that gets transformed in L-glutamate. So if you take a look at our reaction, that looks like this. This is the conversion also to a aldehyde to a beta-alanine, which is a carboxylate. So our reaction doesn't fit into this category, but it does fit into this category because this is the general conversion of any aldehyde into its carboxylate. So these two genes, they have the chance to be involved in this reaction, where these genes should be removed from the manual curation. So let's move forward and let's explore this reaction a little bit more. So I enter the RIA data page for this reaction, and as you can see, there are much more proteins involved into our reaction than in the previous one. We have also easy numbers, and according to our reaction, the directionality is from left to right. So I go to this directionality to see which kind of proteins are annotated into it. And so we enter this link in which I had 17 proteins. And when I come here, I filter by human. The reason I do this is to reduce the number of protein at the least number possible. So you can either do this or not. But the thing is that after filtering, two different genes pops up. And this is LDH1A1 and LDH7A1. And I check the subcellular localization of these genes, and I find out the LDH7A1 is expressed in mitochondria. As you can see from our reaction, this is happening in mitochondria. And while LDH1A1 is only expressed in the cytoplasm. So I remove this from the candidate genes, and I add this new gene to our manual curation. So this is this is another thing. LDH2 and LDH1B1, which are not here, they are annotated in this list of genes in which the direction is undefined. It doesn't mean that it's bidirectional, but it doesn't mean either that it's left to right. I mean, it's protein are not annotated to this reaction, but the directionality is not known. So LDH2 and LDH1B1, which are two of our candidate GPRs, are annotated to this reaction, but are in the part of the directionality has not been defined. So to my understanding, and feel free to leave any comment here on, this gene can still be in the list of GPR final genes, since there is no contradictory information about the participation of this gene in the reaction. However, the fact that LDH2 and LDH1B1 do not have an established directionality, while this one does, LDH7A1, should be mentioned in the curation notes. So in this way, the final GPR for this reaction should be this gene, this other gene, and this final gene. So what we did here is to eliminate LDH4A1, which is this one, which is assigned to this reaction that has nothing to do with ours. And we added a new one, LDH7A1, which is this one here and this one here. And this one and these two genes stay the same. One small clarification. So here you have a human gene, right? And you need to find the CHO ortholog. So usually when I try to find a CHO ortholog, I look for the ID in the ensemble database. So if you need any help on doing that, you can reach out to me and I can show you how to do it. It's super easy. And by doing that, you can get the Entrance ID or the NIH ID for the CHO gene.
Just one comment about that. You can go even faster if you have the name of the gene and you just put it in NCBI, and after you make the gene name plus chrysatilus, which is CHO organism, and most likely you will find it directly, except if it's a a locus that is not yet. But it's really rare. We really found that really rarely. Then
More in this
it goes
well-annotated
it
reaction.
goes even faster. You can stick
No, I
to
totally agree.
NCBI.
Okay, so now we have solved the GPR. Next, let's go to the confidence score reference. So to assign a confidence score, you need to look for information of the existence of the reaction in Chinese hamster and the existence of the gene. This is what I mean with the existence of the reaction in Chinese hamster. So you look for these. I took this example protein. So we have three. I took the first one, LDH1B1, and this protein, at least in UniProt, is inferred from homology. The existence has not been checked at the transcript level or the protein level. So if you look for available publications in UniProt, this is one publication that will pop up in many proteins that are inferred from homology. So you can either take this reference, and since the protein is inferred from homology, the confidence score should be 2, or you can also choose to find some extra information in the literature. So if you happen to find any information that links the existence of this protein in CHO cells or Chinese hamster, and you have a stronger evidence, I will advise you to put that in the confidence score. In that way, you can, of course, increase the number of the confidence score. But let's assume that this is the only information that you have for this protein. So you know that this protein is inferred from homology from this publication. So you put that in the curation notes. You put the information about the directionality of the reaction, and confidence score should be 2. And again, this is important in the references. In the reference section, you put the RIA database link and also the DOI number of the paper involved. So as you can see, this Newman curation is much more straightforward. We're talking here about two databases mainly, which are UniProt and RIA, and the publications associated to those two databases. Of course, you're free to continue with the way that you were doing the manual curation, if it works for you and it's more comfortable for you. And also, you can feel free to look for extra information. If you want to use RIA, you can use it and combine with extra information from other databases or other literature search in the web. That's totally doable. So the idea behind this is to facilitate for you and accelerate the number of reactions curated. So here I'm gonna give you some extra tips on that. So the first one is to identify reaction carried out or catalyzed by the same GPR or GPRs. So on our last mind curation workshop, I introduced this idea to some curators, and I've seen that many of them really improve the number of reactions curated. So I thought about bringing this to this new workshop and suggest the same thing. So when you're curating a reaction, let's say you follow this RIA step and you were able to curate this reaction in 10 minutes, 15 minutes. So instead of going to a new reaction with other metabolites, with other GPRs assigned to them, first try to find reactions that share the same GPR. So for example, here, I took this reaction, which is assigned to this GPR, and I put this in the search bar, and at least 5 reactions popped up that share the same GPR. So it's very likely that these reactions can be curated in the same way. If you can corroborate that the metabolites in these reactions also participate in the description that you observed in RIA, or if this GPR participates in many reactions similar, you can basically, once you make sure that your metabolites are okay, you can basically copy paste the curation that you did previously. So this will accelerate the curation by a lot. As you can see in one of the examples that I gave on RIA, it was the conversion of a aldehyde, a generic aldehyde, to a carboxylate. So many metabolites will fit into that category. Another thing is to identify reactions that share the same group of metabolites. So this follows the same logic. So here, for example, I took this reaction. Let's assume you go through this reaction, you create the reactions, and then you take this metabolite, for example, which is the main metabolite in this group of reaction, and all these reactions share the same metabolites. And if you look closer, they all have the same structure. So they combine this metabolite with one sphingolipid, and it generates another sphingolipid. And as you can see here, many of these reactions share the same GPRs. Here you have this gene 717, 920, 920, 920, 766, 766. So it's very likely that when these reactions, they may follow the same logic when doing the manual curation. And again, if you check that these metabolites are part of the reactions, are part of the information in RIA, I mean, you can basically copy paste the curation that you did. So in the time that you curate one reaction, you could be curating 2 reactions, you could be curating 3 reactions. In some instances, you can curate a group of 20 or 30 reactions at the same time. So I highly recommend you to not focus in one reaction, but look around and see what the reactions share, what are the metabolites that these reactions share, and what are the GPRs that these reactions share. So before we end this seminar, just a couple of reminders. So again, the pre-check tag. Many reactions have a pre-check tag. In fact, there are some reactions that still need to be pre-checked. And if you happen to see some reaction without any GPR annotated to it, you can jump to a reaction with a GPR annotated. So this is important. These reactions are not priority, so I will advise you not to curate these reactions. If you happen to be curating a group of reactions that you want to finish and a couple of these reactions are pre-checked, you can curate them. It's not a problem. It's just we don't advise to do that. Please read carefully the new manicuration protocol. The new manicuration protocol is pretty much what I showed in the previous slides. In these slides, I put basically the entirety of the protocol, but this protocol has some extra information between the images that it's worth reading. So yeah, everything that we discussed today is there in a more detailed way. And finally, remember that we have a deadline for the finalization of the manicuration by November 24th. Yes, Camila, I see your raised hand.
Yes. So if we finish our package, but we haven't done the pre-check, is it better that we do the pre-check or we try to curate another package?
Yeah, that's a very good question. I'm very happy that you raised that. So the quick answer will be to look for reactions in other packages without the pre-check tag. So many of you will find out that most of the reactions in your package are now with a pre-check tag. And at the same time, we want you to use this approach to identify similar reactions to facilitate the curation for you. And this will make you jump to different reactions, probably in packages assigned to other people. So it's not a problem if you curate reaction, even if the reaction is curated already and you want to recurate that. Normally, you wouldn't waste time in a reaction that is already curated and you will jump to another one. But even if you want to recurate a reaction, that's totally fine. If you want to check the job that other curators did, you can do that. You can redefine the confidence score and the GPRs, and you can put your name, your initial next to the other curators' initials. So again, we highly recommend you to more if you are finalizing your package to go to other packages and find reactions to curate. There are some packages that nobody have taken so far, and they have a lot of these similar reactions. Actually, let me see if I can find a good example for this. And these reactions, nobody's taking them. For example, this is, well, these are curated, right? I just missed them. This is a good example, but I want to go this, for example. So these reaction, they have the same name. It happens throughout the reconstruction. You will find reactions with the same name that basically most of these reactions are involved in fatty acid metabolism or fatty acid oxidation, and it involves the same group of metabolites. So you have coenzyme A, and you have the formation of carnitine, and these two metabolites are the one that changes. So it's very likely, if you take, for example, the GPRs are the same in this reaction. It's very likely that this reaction, for example, this group of reactions, they are catalyzed by this gene. They have the same curation process. So, of course, it's not something for sure. You need to make sure that each one of these metabolites fit into the description in RIA. But once you did that, you can curate a group of 31 reactions in the time that you will be curating 3 or 4 reactions. So, and this is not an isolated example. You have plenty of reactions like this throughout the data set. And these packages, maybe in some of them, some people sign up but didn't have to curate, and in some cases people didn't even sign up. So if you're Camila near to the end of your package, or even if you want to every once in a while jump to this group of reactions and give a try to curate all this in bulk, I highly recommend you to do so. I highly recommend everybody to do so and curate this group of reactions that are here in the data set, and they're relatively easy to curate, and nobody have taken them so far. The same applies here. And also there is a group of transport reactions that they have the same characteristics. And yeah, that's pretty much it. So let me go back to this, to the final deadline, which will be on November 24th. It's a little bit more than 3 weeks from now. And we believe that with this new money creation protocol, we already tested this. We believe that this is going to be more than enough to reach a very high number of reactions curated by them. And yeah, that would be all. I want to thank you all for participating in this project, not only the people directly involved in the reconstruction, but also all the money curators that participated in different different aspects of the money creation, like for example, identification of duplicated reactions, fixing unbalanced reaction, curating metabolites, and yes, thank you very much. We reach a very high number of reactions curated, and we hope to even increase this number in the coming weeks. I hope I answer your question correctly, Camila. If not, feel free to re-ask, and unless there is some extra question, or if you want to give a final remark of anything, Em, I can just finish this workshop.
No, fine by me. I think we good. I see there is a question.
Yes, Santiago.
Pablo, we have two concerns. First one is we already curate a lot of reactions, but we don't use the RIA database, so we don't put the link in the reference column.
Yes.
So we should go back and look for the RIA, or it's not necessary?
No. For those reactions that they are already curated, so we assume that curation happened in another context with another protocol, and they're correctly curated. The references annotated to them are correct, and the same with the curation notes and the confidence score. So there is no need to go back and re-annotate the information regarding the RIA database. So this will apply for the next batch of reactions. And again, this is a recommendation. So we advise you to curate this way because it's easier, and it's nice to have the RIA database annotated to our reactions. But if you feel more comfortable curating the way you've been curating, and you feel that the way that you curate is easier, you can do so.
Okay, but in many cases, we don't check for the gene in CHO cells, or in Chrysotulus griseus. We look for the gene only in the human orthodox. So the confidence score have the reference of the human orthodox. So I really don't know if we should go back and recheck the confidence score.
Yeah, no, I understand that, and that's so previously what you did is to annotate the confidence score based on the information that you find in any mammal organism, and you were based so the existence of the Chinese hamster gene was based on the annotations on NIH. And now the confidence score I'm asking you to redefine the confidence score based on the information in UniProt. I don't know. Do you have any recommendation on this, Anne? I seen that you raised your hand.
Yeah, it's not a big problem. Actually, for these things, thinking that is will make an automatic annotation process for this aspect. Specifically here, we could think about regenerating the confidence score in a more automatic way. And what is important when we do that is that we have a training set of data that are manually curated to train the algorithm to do so. For me, there is like two extreme that we need to get is 1 and 4. 1 is really, okay, this reaction is there for modeling purpose, or at least we do not have any reference that indicate that this might really exist in the nature. And 4 is that we sure this reaction happen, and ideally we sure that it happened in CHO. After, it's all the question of how we will attribute 2 and 3. And I think it will be a combination of like knowing this gene actually exists and at which level, and how sure we are about the function. But I think that's, it's again some kind of things that at some point we'll need to make much more systematic. And here it will always be a bias from the curator, either if you attribute 2 or 3. I think 1 and 4 is not a problem, but 2 and 3, it's like, even me, sometimes I'm like redoing a same reaction I did the day before, and I'm like, oh, I attribute 3. No, I should have done 2, and it's really then do not worry too much about that. I think what is important at this level with the ID we have for the next step is that there is reference and notes of why you do that, and not specifically on the number, but like say, oh, these are the reference that I found, these are the gene that are good. And I think the priority also is to ensure that we have the good gene association, because here we changed the focus because we saw that like what is really the most important is like, can we ensure that at least the information that is embedded is correct? And like this information that is critical is like this gene association. Then yeah, then no problem, don't go back to that, focus on other stuff. And but thank you to raise that. We can begin to think about how we after will make it more systematic.
Yes, Jean-Jacques.
Oh, yeah. So actually, I used to utilize two database, for example, like UniProt, and also I use KEGG to cross-check the one genes. In that case, in UniProt, the Chinese hamster gene is for in my case, I'm mostly doing the fatty acid metabolism, and their genes are mostly have annotation score 1 or 2, but in KEGG in KEGG they say that the gene is exist in Chinese hamster. So yeah, in UniProt was annotation score of 1 and 2 means that there is a gene exist in Chinese hamster, but how can I compensate that?
So I will have to take a look specifically to the group of reactions that you're curated, but it could be that they have the group of reaction that you are curating are well annotated in CHO, and they have an easy number associated to them. And by that, they probably have a RIA annotation also. Usually, if they have an easy number, they probably have also the
Yes.
RIA ID.
Yeah.
So one advantage on the RIA database in comparison to KEGG, and I think this is the main one, is that RIA offers the direction annotation regarding the directionality of the reaction.
Mhm.
So this is that is very important to us, because the directionality of the reaction, as you saw from the example that I show you, can define you which group of GPR you keep in the final GPR column. So that is very important. But with that being said, you said that you use UniProt, and then from UniProt you find links to the KEGG database.
But
You
this
find
is
any
this
sense?
is normal.
but yeah.
There is not the same level of annotation in KEGG and CBI, and these annotation level in CBI and UniProt are pretty recent. Then and some protein you would see, you have one transcript that lead to a different isoform, and you have like for different isoform you might have actually different annotation score.
Yes.
Then again. I would not worry too much about that. I would just say that like what is important is like if you know that there is evidence at the protein or the transcript level, you put
Okay.
a higher score. And it's also about like the gene. Yeah, what is important is that the gene exists in like has been even predicted or inferred from homology. After you can say, oh, is there a functionality known with that, and am I sure of this functionality? Then sometimes I have a gene that I will bump to 3, even if it's inferred from homology, because I know it's inferred from homology. It's just there is no I will say manual curation of this specific gene that has been studied, but there is a high homology of the sequence. You can find the same gene in mouse and in human, and you have a bunch of literature that assess the function. For me, that's a 3, and because I know like it's just like most likely nobody has studied this gene in CHO, but and again, that is my evaluation, and I will put a 2 if like typically I know the gene is like infer from homology, but I do not have a strong um, certainty about the functionality of the gene. And I'm like, oh, actually, I'm not so sure that this gene is doing this exact reaction because there is no link in other organism. That is how I differentiate 2 and 3. And 4, that is evident. Like when you come to a 4, you just know that this really exists and has plenty of literature, and there is evidence at the transcript and protein level.
Thank you.
But yeah, maybe Pablo, we can write that down even more precisely if it brings confusion. I know you asked me yesterday to do that, and I maybe have overlooked a little bit, and we could like reprecise this confidence score in like one table of like different combinations, so just people just follow that, and anyway we after use that as a way to train maybe an algorithm for automatic attribution of this score and compare how the automatic attribution will be done compared to manual curation. Yeah.
I can put together a table. I mean, like to streamline and make it more
the trends, but
easy to understand.
Yep.
Okay. Well, if there is no more questions, again, thank you all for joining, and thank you for participating and collaborating with our reconstruction. I will send some information after this meeting, as long with this recording, in case you want to look this again. And yeah, I will keep you updated in the next newsletter and workshop. Bye-bye. Have a
Have
nice
a good
day.
one. Bye.
Have a nice day wherever you are in the world, and I'll keep connected.